Good morning to one and all. My name is Sheikh Mohammed Iqbal and I am from 2CSCD. Today I am going to give a seminar presentation about probability and statistics in the topic of methods of dispersion. So let's move to the seminar. Dispersion and methods of dispersion. So let's first discuss about the what is dispersion statistics. Dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of the data. Dispersion and methods of dispersion. As we can see, the above picture denotes the dispersion diagram. The above diagram shows about the dispersion, how it works. So let's see how it's. So let's move with methods of dispersion. In statistics, the methods of dispersion helps to interpret the variability of data to know how much homogeneous or heterogeneous the data is. In simple terms, it shows how squeezed off certain the variable is. Methods of dispersion. In statistics, the methods of dispersion help to interpret the variability of data, but how much various and homogeneous the data is in. Let's move to the types of dispersion. There are mainly two main types of dispersion methods in statistics, which are absolute measures of dispersion, relative measures of dispersion. So let's discuss what is absolute measures of dispersion. An absolute measures of dispersion contain the same unit as the original data set. The absolute dispersion method expresses the variations in terms of average deviations of observations, like standard or mean deviations. It includes range, standard deviation, quartile deviation, etc. The types of absolute measure differ. There are four types of absolute dispersions. They are range, variance, standard deviation, quartile and quartile deviation. And extra one also there, mean and mean deviation. Let's discuss about individually. Range. It is simply the difference between the maximum value and the minimum value given in a data set. Example, we can see 1, 3, 5, 6, 7. In this, lowest value is 1 and highest value is 7. Range is equal to 7 minus 1 is equal to 6. Variance. Deduct the mean from each data in the set, square each of them, and each square and finally divide them by the total number of values in the data is said to be variance. Variance is denoted by sigma square or pi square. We have formula pi square is equals to sum of all x minus mu square by n. So let's move to the standard deviation. The square root of the variance is known as standard deviation. SD is equals to root sigma variance. Quartile and quartile division. The quartiles are the variables that divide a list of numbers into quartiles. The quartile division is a half of the distance between the third and first quartile. Mean and mean deviation. The average number is known as the mean and the arithmetic mean of the absolute deviations of the observation from a measure of central tendency is known as absolute mean of mean deviation. As we have discussed about the absolute measures of dispersion, so let's move to the relative measures of dispersion. The relative measures of dispersion are used to compare the distribution of two or more data sets. This measure compares value without units. Common relative dispersion methods include coefficient of range, coefficient of variation, coefficient of standard deviation, coefficient of quartile deviation, coefficient of mean deviation. Coefficient of dispersion. The coefficient of dispersion are calculated along with the measures of dispersion when two series are compared that differ widely in their averages. The dispersion coefficient is also called as their averages. Used when two series with different measurements unit are compared. It is denoted as CD. So let's move to the some of the common coefficients of dispersions are. The common coefficient of dispersion of range is x of max minus x of min by x of max plus x of min. The coefficient of dispersion for quartile deviation is Q3 minus Q1 by Q3 plus Q1. The coefficient of dispersion for standard deviation is standard deviation by mean deviation. Mean deviation is equal to mean deviation by average. Let us see some examples of the dispersion. So first let us start with the coefficient of dispersion example of range. See here we have given the data of some of ages and number of person. See here ages are given in class intervals but they are exclusive. So we want to make them inclusive. We also know that how to change exclusive into inclusive by adding 0.5 in the lower class and by minusing 0.5 from upper class. See here we have done the inclusive to exclusive conversion, as we can see here, true class intervals. So let us move to the coefficient of dispersion of the. In these classes, we have the highest is 36.5 and the smallest is 15.5. We have the coefficient of range is equals to 36 by I mean x max minus x min by x max plus x min. 36.5 minus 15.5 by 36 point plus 15.5 is equals to 21 by 52 is equals to 0.4034 is the answer. So let's see an example of the quartile deviation. Here we are given a data of the marks and the number of students. Let us take it. We also know how to find the Q1 and Q3. So we first find the CF to find the cumulative frequency of the given frequencies and then finding CF and frequency by applying in the formula Q1 is equals to L plus N by 4 plus minus CF by F into H. H is the width of the class. After applying the Q1 formula, we get Q1 is equals to 21.670. And like that same Q3 is equals to we have formula L plus 3N by 4 minus CF by F into H. By applying the Q3 formula, we get 37.5. So let's formulate in this the dispersion formula. We have quartile deviation dispersion formula as 1 by 2 of Q3 minus Q1. As we know that Q3 is equals to 45 and Q1 is equals to 21.675 by 2. By applying the multiplication by differencing 45 minus 21.65 by 2, we get 11.5625. So let's move to the another mode deviation, standard deviation, mean deviation. We know that mean deviation is founded by x minus x bar by m. So let's find the mean. Here we have given the ages and the number of frequencies. So let's first study assumed mean. Assumed mean is founded by xi. Xi is formed by lower class plus upper class by 2 into h. By finding all mid values, we get 25, 35, 45, 55, 65, 75 like this. Then we have to choose a assumed mean and then we have to find the DI and again we have to find FDI and we have to value FDI square. We got values of FD and FDI square. So summation of FD is equals to 577 and summation of FD square is equals to 1299 and summation of the original frequencies is equal to 542. So applying the mean formula A plus assumed mean by n into h. We get 45 into 65 by 42 into 10 is equals to 54. And then we move to standard deviation. We have standard deviation formula is equals to sigma fd square by n minus sigma fd whole square by n into h. By substituting the values in the formula, we have fd is equals to 528 and sigma fd square is equals to 1289 and n is equals to 542. So let's evaluate this. We get the answer sigma is equals to 11.67 years. So thank you for giving this opportunity.